to our last speaker of this morning, Professor Carlos Salema. Quick introduction. He was a full professor at the Instituto Superior Técnico since 1979, where he taught telecommunication system until his retirement a couple of years ago. He was invited professor of telecommunications at the Portuguese Catholic University, and currently he is professor emeritus at the IST and chairman of the board of directors of the Instituto de Telecomunicações. He is full member of the Lisbon Academy of Sciences, of the Portuguese Academy of Engineering, and today he will offer us insights on the special topic of information technologies and telecommunication in Europe and in Portugal. Welcome. Thank you.
Thank you, Professor Unterstock. Dear ALLEA delegates, distinguished guests, first let me thank you for your invitation, for your very kind invitation. Just before I start, because I see in the audience somebody I would like to pay tribute to, Professor Graça Carvalho, for her fantastic, I must say, fantastic job on simplifying the procedural rules for H2020. I never forget to say that. I already did it in European Parliament. And I would like also to evoke the memory of a very distinguished colleague of mine who passed away last week and who was really the person who brought about the most significant changes in the Portuguese science map. Finally, let me start. Okay, now I will try to have a very short introduction, then I'll go about a little bit what is happening or has happened in the past 15 or 20 years in Europe, in Portugal, and I'll try to draw some conclusions. Now, the first thing I must say is that the assignment I was given was a very tough one. Why? Well, because the Industrial Revolution means the changes brought about in manufacturing by the introduction of digital technologies. Okay, so I decided to make a small shift in the definition of Industrial Revolution, and I broadened the concept by talking a little bit about the changes brought about not in manufacturing, but in our everyday lives by information and communication technologies. Okay, many of us remember, but many of us forgotten, that after the first experiments of Ørsted and Henry in electromagnets, somebody who had nothing to do with electromagnets, but who was fascinated by the experiments, decided to put them to a different use. And from that different use came the first instrument in communication technologies, which is the telegraph. Morse invented the telegraph in mid-19th century. It's interesting to recall that he did not invent the Morse code. It was somebody else, Alexander Vail, who did that. And in fact, it was also Alexander Vail who found the public support to put the first line of 60 kilometers between Baltimore and Washington. And it was used, first introduction, for a very political event in the United States. Now comes an evolution, and the evolution was how to use variable resistance to transmit sound. And that first idea was brought about by Alexander Graham Bell. It's quite interesting that he demonstrated the telephone in a very unlikely booth because he was late in arriving to the exhibition, so they gave him a very secluded booth somewhere else. That he brought about probably one of the major revolutions of the end of the 19th century. Okay. But what happened later? Again, a mathematician, James Maxwell, following the ideas that were put together, but not in a very precise way, by Michael Faraday, decided mathematically that there was something that he called the electromagnetic field. These are the equations I put in on the left, on the form that they were not the form used by Maxwell, but the form used by later Oliver Heaviside, and the same form we use today. And 10 years later, in almost the end of the 19th century, Hertz demonstrated that the hint that Maxwell had, that there was really an electromagnetic field, was true. Because many people did not believe in the ideas of Maxwell. That's interesting, and that's just a picture for the experiment where Maxwell demonstrated that this was true. Now, it's interesting to state that Hertz, you know, the great physicist that proved the ideas of Maxwell, did not believe the electromagnetic field was useful for anything. That when a journalist asked him, what do you think this was used to? He said, I don't see any useful way of making the use of the electromagnetic field. Well, but a very young man, and quite a few others, this one was probably the first who patented it, Marconi, saw a use, and the use was to communicate between 2 points which were not connected with a physical line. And he proved it, in fact, quite interesting, against all the brilliant physicists of the time. He proved that he could transmit from, in fact, it was from the United States, near the United States, to the UK. He proved it both ways, from the UK to the United States and back. But, you know, the good physicists of the time said it was impossible, because they knew that the electromagnetic waves would propagate linearly, and then the bulge of the Earth would come in the path, so that was not possible. Of course, they did not know that there was something called the ionosphere. But, well, Marconi didn't know either, but he intended to prove that that was possible. And indeed, it was possible in 1902, and he managed to communicate between a ship somewhere near the coast of the United States and the UK. It was interesting because his work was questioned, but he was very, very stubborn and continued, and in fact he got a Nobel Prize before Einstein, something not everybody remembers. Okay, then you come again the new inventions, the diode by Fleming and the triode by Lee de Forest in the first decade of the 20th century. And by 1920, there was something quite magical at the time, that was radio. Radio became a thing of our houses at the time, and that was a way that changed the way news were communicated. Well, then after radio, we had something else which was interesting. I just brought up radar. Everybody thinks of radar as coming in the Second World War. Wasn't true. In fact, even Marconi devised radar, and the first patent is by a German inventor. And nowadays we cannot fly any airplane. In a few years' time, we cannot use any car without radar. But nowadays, it's still a little bit remote from our everyday life. Television, on the other hand, brought about a complete revolution in the way even we live and we arrange our homes. And that started in the late 30s, publicly, in the labs before. But what has happened is that it was first black and white, first low definition, nowadays high definition, full colors, very soon three dimension, and our houses are arranged around the television in many cases. Okay. Well, the third and the last point of this introduction would be to recall the Eniac. That was in fact, it was started during the Second World War in '43, but it was only finished after the war, and it took more or less 150 tons of equipment, and it was far less powerful than what all of us have in our pockets or purses, which is this. It was far less powerful. Anyway, it continues, and then computers started as calculators, then they went from calculators to processors of information, and from processors of information they tend now almost to rule our lives, but that's something else. Computers used to be isolated, but after a project which started as a military project, the ARPA, in the United States, they started to be connected. And this is just, you know, a hint of what internet now looks like in the world, a little bit of the internet, and that's really something that connects all of us and all of our lives. Okay, so this was just to recall in a very sketchy way what has happened since the beginning, the middle 19th century to nowadays the 21st century. Okay, so let's see what has happened in Europe and a few areas. Now, let me talk about mobile communications. Mobile communications were, in the beginning, an idea that started in the United States, but basically what has happened is that Europe, by a very clever arrangement of standards, in fact, what we call the GSM, caught in the beginning of the 1920s the world market, almost by storm, and had the lead in mobile communications. Okay, but what happened is for many, many reasons, Europe lost the lead and is now trying to regain it. And on H2020, one of the things which is pretty important there is what we call the fifth generation of the mobile communications, which provides maybe a way for Europe to regain the lead it used to have in mobile communications. Let me now draw a different thing. I was fortunate enough to work with the person who first, in 1966, proposed optical fibers, which had been discovered many, many years ago by physicists as usual, as a way to make a highway for communications. And the first broadband fiber optics network was built in Europe, and Europe still has a lead on the optical fiber communications. The research kept going, and there's, I think, I'll show you a little bit later, that Europe has here a possibility due to its very good communication infrastructure. Okay. Now, something that comes more recent to our life, digital audio and video. Again, Europe started it by the MPEG group, the Mobile Picture Experts Group, and many of us, at least most of my sons and grandsons, know all about MP3 for their music, but they don't know that MP3 was the European standard for digital television that was started in 1991, I think, or 92. Okay, Europe had the lead, but Europe lost the lead, and now the lead is somewhere in Southeast Asia. Let me just do it a little bit again on television. The same thing happened as for radio. Now, in the internet, there was a very important project in FP6 and 7, if I am right, which was GEAN. GEAN was probably the major push that Europe had for international communication by providing a network that linked many scientific communities, not only over Europe, but also extending to the United States, to South America. It is said that it's probably the most impact project ever performed at the framework programs. Okay, now what about applications? Applications, again, something which is not very nice. The first World Wide Web was devised in Europe at CERN, but then Europe more or less lost the lead almost as it started, because the first browser, something that we use every day, was devised in the United States. It was called Mosaic, then Netscape, now everything else. Then you have the web browsers, which we use to find out what's on the net. They are American, and Europe is now lagging the United States there. But I have and I see a hope, and the hope is that Europe has a superior infrastructure, communication infrastructure. So that gives a window of opportunity to have new and better things. Let's see if Europe can take it. Okay, now I'll go back to Portugal, and something which is interesting. Some of you will know that, some of you don't. In Portugal there are about 10.5 million people, but 21 million cell phones. That is two per Portuguese. But it's a bit crazy. It has reason for that. And the reason was, and the decline you see in the end of the curve had to do with the market, because every operator had his tariffs for the cell phones with the same operator. So everybody had to have at least 2 cell phones to make sure that they had the best deal with 2 operators, not only one. Okay. The interesting thing about it is that Portugal invented the prepaid cell phone. Something is not known. And the first world prepaid cell phone was here in Lisbon, in fact. It was in 1995. Now, the prepaid cell phone looks like something strange, because the person who invented it thought it was so simple that it cannot be patented. It's amazing nowadays. 20 years later we say, how can it not be patented? Have you ever seen a patent for an iPhone? If you have seen, you will see that's a box with dimensions, and that's it. But okay, nowadays 70%, more, in the world probably 80% of all cell phones are prepaid. In Portugal about 70%, in very rich countries far less. Okay, so about mobiles. Now about fiber optics, that's the second subject I talked to. I like to see Portugal there. 90% of the homes have fiber optic up to the home. And that's not my own data, it's the Council of Europe data that I took. And you see, it's quite interesting. Portugal and Spain have very high penetration of fiber optics. Okay, so now I'll go into some applications. And in the applications, I'll talk about just a few. But now, cash dispensers is something that you find everywhere in the world. But in Portugal, you can do unusual things in the cash dispensers. Not only you can get cash, of course, you have the right card, but you can pay your taxes, you can pay your bills, you can transfer money, you can buy train tickets, you can buy cinema tickets, you can do virtually everything in a cash dispenser. That's unusual. Second thing which is unusual is the amount of points of sale. I think that in Portugal you can almost live without money, provided you have a good credit card or debit card, because there are 250,000 points of sale, and they are everywhere. I mean, really, in the most remote places, you don't have to have money to buy anything. Provided you have the card, that's it. It's quite amazing. The number of transactions in this company, which deals with the credit cards, is unbelievable. It's 20 billion a year. 20 billion a year, it's a very large number. Okay, fine enough. Another thing, again, on the cashless society. This is half Portuguese, half Norwegian technology. Well, most of our motorways are tolls, so you have to pay toll to get through the motorway, but you don't have really to pay with cash. You can have a little box, put it in your window screen, that's it, drive through, and you don't stop. But you can use this also to park, and you can use to buy gas, so you really don't really need to have cash with you, provided you have this thing. And these are just few applications of the motorless society, of the cashless society. Finally, what about personalized TV? Very few people know this thing, which is pretty new and not very usual. Now, you can really choose what you want to see on your TV, provided it has been there for the past week. You just say, oh, I want to see the program that was passed 3 days ago at 4 o'clock in the afternoon because I was working, I couldn't see it. Just, you know, switch to the channel, say 4 o'clock, and that's it. You have your program there. But it's more than that. You can have your own personal channel, TV channel. You don't pay more for that. Since you have broadband, very broadband, fiber optics in your home, you can define your own channel when you can upload your videos or your pictures or your whatever, and you can give access or no access. And this is a service which is available every home. So this is what has happened in the recent years in Portugal. I would just like to conclude with some conclusions and recommendations, if I can call them that way. I think I have been able to tell you that fundamental and basic R&D, it is a key for disruptive innovation. And you never know when you discover something what you can do with it. Very seldom you can know. Nobody that invented the laser ever thought that could be used to perform eye surgery. Nobody. But that requires normally public money to do. The second thing, something that the Nobel Prize a couple of weeks ago told me about, and I thought he was very, very wise in saying, in order to have good science, you need two things. That's trust and time. The time span between discovery of something and putting it in the market, it can take 15 years if it's fast. It can take 50 years if it's slow. So don't rush. You cannot have a product on the market in 2 years, unless you have everything done already. Third one, standards are vital. And that in Europe has been proved time and time again. If Europe doesn't have its own standards, it will be conquered easily by those who have their standards or impose their de facto standards. Third and fourth, it's the regulatory action. This is important basically in telecoms. I'll just use one very small example. Wi-Fi. You have Wi-Fi here. I've seen the password, one coming in. But Wi-Fi is a breach of all the normal regulations in telecoms. It's an unregulated bit of spectrum. If you put the regulators really in their place, you know, holding for dear life to their spectrum, you will not have Wi-Fi. And that's life. First and last is the public openness, openness of authorities to embrace modern things. If public authorities don't believe in email, you go back to what? A written letter sent by mail? But that can happen. And so that's why I think it is also important for the development of information and communication technologies in our lives that the possibilities offered by science and technology are allowed by the regulators. Thank you very much.